Good morning. Welcome to the live session. We discussed in yesterday's live class about refraction of light at curved surfaces. So basic information regarding refraction and curved surfaces that we discussed. So here in this, we'll discuss about the terminology related to the curved surfaces and behavior of certain light rays related to the curved surfaces based on the medium. So in the last class, I discussed with you about mainly what is refraction and cause of refraction. So what is refraction? Simply, refraction is nothing, bending, deviation of light. So here, deviation of light from its path when there is change in its medium. So without change in the medium, there is no deviation of light. So here simply you learned about rectilinear propagation of light. Rectilinear propagation means going in a straight direction. So almost the light goes in a straight direction, but if there is change in the medium occurred, then what happens? Automatically it deviates from its path, bending in a direction. So that is called as simply refraction. Cause is change in the medium and change in the speed. So already we learned about that one. So now our discussion is about terminology of curved surfaces, right? So here in the refraction, especially we are dealing with the curved surfaces. So here simply that arc-like shape, always changing its direction, right? So that bent surface is called a curved surface. So here in this curved surface, one side you may observe as bulged out. So curved outwards, out, existing, X. So that's why here I'm giving the name for this surface is convex surface. Curved surface now named as based on its nature, bulged out, existing, X, convex surface. Then one more surface is deep inside, inward. So cave, inward mean. So here that's why I'm naming this surface as here simply inward surface as concave surface. Concave surface. So here one side I'll imagine the simple medium is called a rarer medium, air, and the other surface I'm shading. So that shaded region represented here denser medium. So optical density of the material medium is changing. So that we are calling, depending on its refractive indices, one may be considered to be rarer medium and the other may be considered to be denser medium. So here water, suppose that shaded region representing water. So that is denser medium, and the other side nothing is shown. That is simply here air, called a rarer medium. So these are the terms we are dealing in this curved surfaces, right? So convex surface, concave surface, bulged outward and curved inward. Then denser medium, shaded region, rarer medium without any shading, unshaded, right? So now here we will understand about certain light rays behavior with the curved surfaces, right? So here to know about this one, simply I'll consider a parallel beam of light. So before going that, I'll give you few terms related to this curved surface again. Here simply on the curvature, I'm identifying the midpoint. So here shaded region given as denser medium and unshaded region is given as rarer medium, air. Then That red color spot is given on the curvature. That is exactly midpoint on the curvature. So the midpoint on the curved surface on the curvature is now given as pole. Is given as pole. Then this curvature is a part. If it is two-dimensional, a part of a circle, we may call that as arc. If it is three-dimensional, so it is imagined as a part of a sphere. So whatever it may be, it is a part of circle or maybe a part of a sphere. It is made apart from a complete circle or sphere. So that has center. That center only act as center for this curvature, called as center of curvature, denoted by the letter C here. Denoted by the letter C. Then I'll try to connect these 2 points using a straight line. The line which is passing through this pole and center of curvature. Pole and center of curvature. The line, imaginary line actually. The imaginary line which is passing through the pole and center of curvature, now given as principal axis. Given as principal axis. Then here look at a parallel beam of light rays is constructed to parallel to the principal axis. A parallel beam of light rays incident on the curved surface, that which is parallel to the principal axis. So these beam of light rays now considered to be incident light rays. Incident light rays. Then we need to know the behavior of these light rays after changing its medium. After changing its medium. So here simply to understand about these, we need normal. As we learned in the 9th class. So here what are the normals? The line which is connected, which is connecting center of curvature and the point of instance. So what is point of instance here? This is point of instance here. This is also point of instance. Point of instance. So here different points are there. Everywhere we are connecting with dotted lines. Here that dotted line is exactly perpendicular to the tangent. Tangent meaning is nothing. The line which is perpendicular, the line which is coincides with the circle or the curved surface only at one point, that is exterior to the circle. That is exterior to the circle. If you observe this dotted line and this tangent, how they are perpendicular. So that's why this dotted line which is connecting the curvature and the center, that is called as here normal. So here we have normal. So as you learned here, you can connect all the point of instances from the center of curvature. They are called as here normals at the given points. Right? So here the line which is connecting the pole and center of curvature, in between them, it is also a normal because it is a line joining the curvature and the center. So it is also perpendicular to the tangent. So we can consider as normal. So normals we learned in this topic. We learned about normals in this topic given as figure number 2. So already I have given explanation for this figure. As we are observed in the 9th class. So here at this spot, simply at this spot, we will consider angle of incidence and angle of refraction. So look at this. Here the angle of incidence and angle of refractions are different. Here simply rarer to the denser, angle of incidence and angle of refraction comparison. Rarer to denser. So in the denser medium, light ray observed bending downward towards the normal. So that's why here the comparison is taken to be less than angle of incidence is greater than angle of refraction. So angle of refraction is smaller. It is smaller. So here simply we will see that angle smaller in the denser medium compared to angle of incidence. Suppose it is from denser to the rarer. Denser to rarer. What happens? Angle of incidence will be smaller. Angle of incidence will be smaller comparing with angle of refraction. So these we observed. So simply I gave you one code, RTDT. Rarer to denser towards. Rarer to denser towards. What towards? Towards normal. Towards the normal here. So here light ray bends towards the normal if it is propagating from rarer to denser. So that is enough. Here we will reverse it. Opposite. Conversion. Denser to rarer, away from the normal. So these are helpful to you in this chapter. So that we observed from this figure. Pencil inserted, immersed partially, 50-50 into the water. Then we'll go for another. So here we observed that angle of incidence and angle of refraction. Now, certain light rays behavior with the curved surface propagating from rarer to denser. Rarer to denser. Now look at here, I'm taking one curved surface and shading one of the surface, right? So that shaded region is denser medium and the unshaded region is rarer medium. So unshaded region, air, rarer medium, and the shaded region is denser medium. So remember that. Then here the point identified on the curved surface, curvature, red spot is given as midpoint on the curvature called pole. Then center of curvature you can identify, given or identified as C. Next, joining that pole and the center of curvature called the principal axis here. Principal axis. Then simply you have to consider light rays here. The light ray which is propagating along the principal axis. What happens to this light ray after refraction, changing the medium? So here simply up to this region, it is in the medium called air. After this point P, it is propagating into the another medium called denser medium, here water. What happens to this light ray when it changes its medium at the interface? That is curvature here. That is curvature here. Simply what happens? So here simply if you observe carefully, here you can draw a normal. You can draw a normal. So here I am showing you the normal here. That normal is what? Simply the line which is connecting the center of curvature and the curvature. So this point to this one, extend it for any length. So this is normal at the point P. So here that line along the normal, in this case, angle of incidence and angle of refraction both are same. Both are same here. Angle of incidence and angle of refraction both are same. What that value is here? Simply that value is equal to 0. That value will be equal to 0. So simply angle of incidence and angle of refraction both will be equal. That value will be is equal to 0 because simply they are along the normal. So in this case, there is no deviation. There is no deviation. Light ray remains along the normal after refraction. After changing the medium also, it can remain with the same line, that is undeviate. So after refraction, the light ray propagates along the principal axis, remains undeviate along the principal axis. Then, if any light ray passing through center of curvature, directed towards the center of curvature, look at here, a light ray is considered, it is simply directed towards. So I will show you with a line from this point. So here I am extending. See here how it is directed towards the center. Directed towards the center. So what is normal in this case? What is normal in this case? The normal is simply that red color line. The line which is connecting the center and the point of incidence on the curvature is called. If you extend that red color line outside, then it is along that light ray here. So the light ray along the normal now. So in this case also, angle of incidence will be equal to angle of refraction. That is equal to 0 degrees angle. So in this case also, the light ray remains along the straight line. So simply that light ray goes in the straight direction. The light ray goes straight direction because here angle of incidence and angle of refraction both are equal. That is equal to 0 degrees. So light ray along the normal, remains undeviate. In any direction. It is from denser to rarer or rarer to denser. Rarer to denser or denser to rarer. In any direction, the light ray remains undeviate. So this we learned in this figure. So that light ray, if incident on a curved surface along the principal axis or along the normal, both are normals only. So in this case, angle of incidence and angle of refraction both are equal, that is equal to 0. That's why they are remain undeviate. So this will learn in this. Then here it is given in the figure number 3. Now we'll go for another. That is simply here. It is about the light ray which is parallel to the principal axis. Suppose here I am taking a curved surface and convex surface side, consider rarer medium, and concave surface side consider denser medium. So curved surface is represented left side convex surface, right side concave surface. Here convex surface is in contact with the medium called air, and the concave surface is in contact with the medium called denser medium, that is water. So rarer medium and denser medium we noticed, observed, identified. Then what happens if a light ray incident parallel to the principal axis? So now draw the principal axis. So pole identified, identify the center of curvature. Then the imaginary line connecting or passing through the pole and center of curvature is called the principal axis. Okay, I have that. Then now take a light ray that which is parallel to the principal axis. Remember, draw always a parallel line using the width of the scale. Just you can put your scale equal to the width of the scale above the principal axis. Suppose here I am placing the scale like this. So it is width of the scale, right? So now you can draw your line just above it. Just above it. Simple. It will be easy for you. It will be easy for you. So I got it. Exactly, it is parallel to the principal axis. Just using the width of the scale. Nothing to worry. Parallel line drawing is very easy using the width of the scale. Just you can draw it. Then what happens? So for that, what you need after drawing the parallel line to the principal axis, represent it is as a light ray. Then remove your scale from there. After that, use scale to connect the point of incidence and the center of curvature. Then draw a dotted line as you see on the screen. This dotted line represents a normal here. Now, what happens if a light ray parallel to the principal axis and incident on a convex surface, then propagating into the medium called the denser medium? So simple. I am not giving importance to the medium. Sorry, I am not giving importance to the surface. I am giving only importance to the mediums and propagation direction, right? Or direction of propagation. From which medium to which medium the light ray is propagating. So direction of propagation and the medium is important, not the surface. So here simple. Whatever it may be, the surface is given to you. Use the code RT. TT. Rarer to denser towards the normal. So here the light ray incident on the convex surface is in the medium rarer and propagating into the denser medium. Then what happens? I'm using the same code RTDT, rarer to denser towards the normal. Then what happens? Light ray bends, deviates from its path. That angle will be decreased because towards the normal. Angle of refraction is smaller than the angle of incidence. So here you will notice something angle here. Take it as angle of incidence. So just less than to this one, angle of refraction, you can take it. Then just extend the light ray by connecting them. Simple. Then it will be given you. So here simply, if a parallel light ray parallel to the principal axis, parallel light ray means parallel to the principal axis. The light ray which is parallel to the principal axis incident on a convex surface and enters into the denser medium. After this, what happens? The behavior of light ray we are observing, it meets the principal axis. After refraction, the light ray meets the principal axis. So that is the observation given in the figure number 4A. That is given in the figure number 4A. Now I will consider parallel light ray that is parallel to the principal axis only, but the change is surface. Now here simple, change in the medium now. Change in the medium it is. Right? So here parallel beam of light, parallel light ray that is parallel to the principal axis. So identify the pole and identify the center of curvature. Then you can complete that drawing of principal axis. Okay, completed. Next here, simply identify the mediums, denser medium and rarer medium. So in the previous case, I considered the medium towards the convex surface side as rarer medium. Now towards the convex surface, I have denser medium and concave surface side, rarer medium. Same light ray, parallel to the principal axis, incident on a convex surface. Okay, instant. Then what happens? That depends on the direction of propagation. Denser to the rarer. Denser to the rarer. So here the light ray parallel to the principal axis in the denser medium and it is to the rarer medium. D2R. Denser to rarer. So here it bends away because I know RTDT, rarer to denser towards. So in the denser to rarer away. So I am using this logic. So here now construct the normal from the center of curvature to the point of incidence. Then just have an idea about the angle of incidence here. Then in the rarer medium, angle of refraction increases or decreases. Get an idea using this code. So away, angle of refraction will be greater than to the angle of incidence. So it is giving you idea moving away to the normal. So construct your light ray, increasing the angle greater than the angle of refraction. So normal drawn and identified that angle of incidence something, then constructing the light ray. Increasing the angle of refraction. Look at here. Simply I changed the angle of refraction. That is, as per the logic here, change it. So I'll get an idea. So what happens in this case? Light ray is going to meet the principal axis for any extension? No, do not meet. But if you extend that in the backward direction, that certain light ray meets the principal axis at a certain point in its backward direction. So this is appear to diverge. We can call it as appear to diverge from that point on the principal axis. So this is we observed from this light ray and the diagram. So now we are changing again. So now I will consider the same convex surface, rarer medium side, and the concave surface is denser medium side. Then identify its pole and center of curvatures. Then air is rarer medium, water is denser medium. No importance to the surface again. Just I am depending on the RTDT, means rarer to denser towards the normal. Right now, principal axis is drawn. Next, select a light ray. Now here, denser to the rarer medium. Now here it is from denser to the rarer medium and meets the concave surface here and meets it at concave surface. On the concave surface, now you are incident that light ray. So when a light ray incident on the concave surface directed to the rarer medium, from denser to rarer medium, then what happens? Same code I will follow. What is that? Here simply denser to the rarer, away from the normal. So now I need normal. The line which is connecting the center of curvature and the point of incidence is called normal. Okay, normal is drawn. Just get an idea about this angle of incidence. Then denser to rarer, it bends away from the normal. So angle of refraction increases comparing with angle of incidence. So now increase angle of refraction. So this side you are going to measure angle of refraction that must be greater than angle of incidence. So it bends away from the normal. And it is going to meet the principal axis on further extension. If you extend that light ray after refraction, it meets the principal axis at a certain point. So in two cases, I notice now that light ray meets the principal axis after refraction, but not depending on the curved surface, just depending on the rarer to denser medium. So these light rays behavior with the curved surface we are generalizing. So now we will go for another here. So light ray again parallel to the principal axis, but now the change is one medium to another medium. Previously denser to the rarer, now rarer to the denser medium. The light ray which is parallel to the principal axis and incident on a concave surface and directed from rarer medium to the denser medium. So now we have the code denser to the rarer, away from the normal. So angle of refraction will be greater than angle of incidence. Then now connect that point of incidence and the center of curvature using the dotted line called normal here. Okay, normal is drawn. Then got an idea about the angle of incidence here. Now select angle of refraction, that is greater than, sorry, another side to the normal. So here it is another side only. It is above to the normal. Then you are selecting below the normal, opposite side. Okay, selected. Now construct the light ray. Is it bending towards the normal or away from the normal? So here, rarer to denser. Rarer to denser. Light ray direction is rarer to denser. So simply rarer to denser towards the normal. So here what happens? Angle of incidence is observed smaller than, sorry, greater than angle of refraction, rarer to denser. So based on that, simply here I drawn this light ray. I drawn this light ray. So I got it. Rarer to the denser towards the normal. So here the light ray is observed propagating from a rarer medium towards the denser medium. So RT dt. So based on that, this discussion completed. Now we'll go for another topic, that is simply here about a lemon. So simply from the previous, what we concluded, in two situations, you are observing, they are given as cases actually. So in the case one, what we noticed, that light ray bends towards the normal. In the case two, that light ray bends away from the normal. In the case three, bends towards the normal. In the case four, that light ray bends away from the normal. In two cases towards the normal, in another two cases away from the normal. So that we are generalizing here from the cases, right? So here now we will go for another topic, that is here simply what happens if a lemon is immersed in the transparent glass of water. Why a lemon appears bigger? Why a lemon appears bigger when we observe in a glass of water? In a glass of water. So when you drop a lemon into the glass of water, you will observe that it is bulked in size, enlarged. Viewed as big size lemon. So what may be the reason? So here the reason may be change in the medium. So how to understand that? Simple. Here take a table, put one cylindrical shape of a beaker or the glass, then fill it completely with the water. So now I'm dropping that lemon, right? So here when the lemon is observed from the glass without water, so you will get something idea about a size of lemon, about the size of a lemon. So here now just keep it this in your mind, have an idea, then simply add water into the beaker or the glass. So what happens when we add water into the empty glass which contains a lemon? So adding water, simply observe what we noticed, that is simply the size of lemon is observed as big, larger. So look at again, a lemon dropped into the empty glass. So having something idea about its thickness, then here that lemon will be in the water, thinker. So adding water into the beaker slowly. So while adding also you are able to realize that lemon observed as big in size, not as previous. So bigger in size. Why the size of lemon changed here? Why the size of lemon changed here? So what maybe we can notice, That is because of water only, maybe. The simple reason we are expecting, because I added water. In the empty glass, if you observe lemon, nothing. Just I observed the size of the lemon, something, then pouring water into that lemon beaker. The lemon and the beaker. So here what happened? The size is improved, enlarged, big in size, observed by us. So here simply with this, what I am able to explain with the help of ray diagram. So simply the size is bigger, enlarged image is formed. Enlarged image is formed. So here compare the sizes. Same lemon, but outside the glass having something small size comparing with the lemon which is in the water, immersed completely into the water. So here we will get the reason for that. We'll get the reason for that using the ray diagram. Using the ray diagram. So that light rays we are receiving, from the denser medium to the rarer medium. Denser medium to the rarer medium. So we know that already. That is simply rarer to denser towards the normal, or denser to the rarer away from the normal. So using the same concept, here you are able to observe. Look at this. Up to this normal, the light came in this direction. But here, after changing its medium, so here angle of incidence will become smaller than angle of refraction. Denser to the rarer, light bends away from the normal, So that's why here you are observing this light ray moves in this way, but our eye can estimate that light is coming from a certain point lying above the lemon. Just it is above the lemon. So simply for this also you are able to explain that. Suppose here what happens at this line. Suppose the light is coming, just making certain angle with the normal. Then what happens at this place? It will be bent like this and reaches the person. But your eye can view that the lemon will be at this spot. So that's why you are able to see this lemon in big size. We can see that lemon is big size in the transparent glass of water. Okay, so this is we are understanding why the lemon size improved or more in size comparing with the lemon which is in the air. So same lemon dropped into the water, but the sizes we noticed different. What we noticed, sizes are different. That which kept in the air and the lemon which dropped into the water. They both has simply difference in their sizes because of medium here. That image we are viewing, not the object. So here improved size that we are observing image of the lemon. So we have seen that lemon image. So here the size is changed due to refraction of light. Next, here the topic will be change. Here simply again I am giving you idea about the surfaces here, right? Image formation with the convex or concave surface. Simply it is a curved surface. So with the curved surface, image will be formed or not? Yes, it forms because a lemon is dropped into the water and we viewed that its image after a refraction. We viewed that image of the lemon. So how the image will be formed will be observed in this case. So concave and convex surfaces, simply curved surface is drawn. Then shading one of the region. Suppose I shaded that region, concave surface. So shaded. Now identify the rarer medium and the denser medium. So here shaded region is denser medium. Then another one is rarer medium. Take that refractive indices of the mediums. So rarer medium refractive index, we will take it as N1, and the refractive index of the denser medium will be taken as N2. Right? So N1 and N2 are refractive indices respective to the medium. So N1 refractive index of the first medium, N2 is the refractive index of the second medium. So consider. Then now identify its pole. Identify its pole. Then next identify its center of curvature. So given as C. Now join the pole and center of curvature using a straight line. Using a straight line called as principal axis. Called as principal axis. Okay, I have pole, center of curvature, and principal axis. Now let me consider an object which has point size kept on the principal axis at a certain point. So I am taking a certain point on the principal axis. Then the point object will be placed. Point object will be placed on the principal axis at a certain point, giving you as O. Object is placed at a point called O on the principal axis, and the size of the object is point size. Then will it form any image or not? If it forms, where we can see that image? On the surface or on the screen? On the surface or on the screen. So simply here that light rays will form the image. So considering a light ray along the normal towards the principal axis, along the principal axis or along the normal, that remains undeviated, so goes in its exact path. Then now that point is considered for the second light ray, that which making angle with the principal axis, making angle with the principal axis. So here the angle is considered at the point O. Then what happens to that light ray after refraction from the curved surface, through the curved surface? Okay, so here simply what happens will be decided by normal. So normal is dotted line, that which is connecting the center and the boundary. Okay, I have a angle here, that what angle made by the light ray with principal axis is taken to be angle alpha. So here I consider from the point source object one light ray passing along the principal axis and the other light ray passing onto the curved surface, making angle with the principal axis. So consider taken as alpha. So what happens if any light ray incident on the convex surface and propagating from rarer medium to the denser medium? So simple, consider the normal here at a point A. So normal is drawn. Then identify the angle of incidence at a point A with the normal. So here that light ray is making something angle at the normal drawn between center of curvature and the point A. Now identify that angle as unknown value. Theta 1 is given to you. Then next, what happens to that light ray when passing from one medium to another medium, or called the rarer medium to the denser medium? So in the propagation direction, simply we can observe the mediums, that means optical densities. So rarer medium has optical density less, and denser medium has optical density more. Simply what happens, rarer to denser, that light ray bends towards the normal, extend it to meet the other light ray which is propagated along the principal axis. So they are coinciding one to each. So here at this spot, they can meet each other. So that point we will consider as image point. So the image will be obtained at a point called I here. So I is the image point. So like this, we can explain the formation of a image by the curved surfaces. Like this, we can explain the formation of a image. So the image is formed by the curved surface, as you see here. Then derivation of the formula using the relation between the refractive indices, objective distance, image distance, and the radius of curvature. So use that terms to give a proper relation between them called a curved surface formula. So let us derive the formula. Let us derive the curved surface formula. Here, how do you connect? How do you derive? Here, simply we will depend on the diagram information what I draw now. Simple here. I am going to identify the angle made by the refracted light ray with normal called angle of refraction. That I am taking as θ2. Now I am taking two more angles here. The angle made by the normal with the principal axis. Angle made by the normal with principal axis is identified as something unknown value beta. Then here refracted light ray also making angle with the principal axis. That angle I am considering. So consider that angle made by the refracted light ray with the principal axis is another angle here called gamma. So alpha, beta, gamma. These are the angles we have. Simply here to make the triangles as right angular triangles, what I am doing here, simply I am drawing a perpendicular onto the principal axis from the point A, as you see here. So connect point A and principal axis with a line that perpendicular to the principal axis. So now the line is drawn. So it is perpendicular. So I notice that point where that normal meets the principal axis, or the perpendicular line drawn from the A meets the principal axis at a certain point, taking as N. The point represented as N here. So almost all the information we have here. What they are here, rarer medium, denser medium, angles and right angular triangles, etc. So here now look at the distance measured or the gap length measured between the pole and object called as object distance. Then the length measured between the center of curvature to the pole, that length we can call as, simply it is radius of curvature. Pole to the radius is given as now radius of curvature of the given curved surface is R, capital R. Then image formed at a point I. So now I am able to measure the length between pole and the image point. So pole to the image distance, the length you are measuring is called simply image distance. That is V. So represent that as V here. So I know object distance, radius of curvature, image distance, and also we know the angle of incidence, angle of refraction. So we have a relation. Angle of incidence to the angle of refraction, we have a relation. That is what Snell's law. That is giving you the relation between the angle of incidence and angle of refraction. Right? So that we have an idea. So make it smaller and keep it at one corner. Okay. So we want to set that image at a particular distance, So simply here we can go for that relations in the triangles. So for that, simply what I gave you, pole to the object is given as simply object distance represented as u, and pole to the center given as radius of curvature. Pole to the center is given as radius of curvature, and image distance is given as pole to the image pi is taking as v. So I have three distances. One is object distance, one is radius of curvature, pole to the center distance, then another is pole to the image distance. So I have u, v, r respectively, right? Then now to establish a relation between the quantities measured or mentioned, in the first statement. So u, r, v, right? So that is called here simply relation is curved surface formula. CSF, curved surface formula. So now for that I am depending on the triangles. So here look at that triangle ACO is taken. So this you can observe carefully in the diagram. So now I am giving you the diagram in a enclosed figure ACO. Where is that? Here simply the triangle is ACO. Here simply okay, highlighted in this. So here ACO triangle is selected. In this, just you need to observe, is there any exterior angle? Based on the exterior angles, you are establishing the relation. So what are exterior angles you have here for the triangles? Theta 1 is one of the exterior angle, and beta is one of the exterior angle. So first we will go for exterior angle theta 1. So here for the triangle ACO, theta 1 is exterior angle. We conclude that exterior angle is equal to sum of the two interior angles, opposite interior angles. So now we can establish a relation between exterior and interior angles. So here exterior angle is theta 1 and interior angles and opposite alpha and beta. So here sum of the interior angles will give you exterior angle. Sum of the interior angles is equal to exterior angle, or exterior angle equal to sum of the two interior opposite angles. So alpha plus beta is written. Now find out, is there any another exterior angle here? That exterior angle in this is beta for the triangle ACI. So now from the triangle ACI, what I can establish a relation between exterior and interior angles. So that I can write beta is equals to theta 2 plus gamma. Then if you observe carefully in the relations, theta 1 is angle of incidence, theta 2 is angle of refraction. Let us find out angle of incidence and angle of refraction from the figure. So theta 1 is equal to alpha plus beta, and theta 2 is equals to beta minus gamma. From this relation we are writing, right? So here theta 2 is equals to beta plus gamma, transposing that gamma from one side to another side, RHS to LHS. So plus will become minus. So beta is equals to theta 2 plus gamma. From that, theta 2 is equals to beta minus gamma. So I know this is as angle of refraction. This is I's angle of incidence. So directly we have a relation between angle of incidence and angle of refraction that we learned in the class 9, 9th class. So here theta 1 and theta 2, theta 1 and theta 2 are simply or respectively angle of incidence and angle of refraction. Angle of incidence and angle of refraction. So the relation between angle of incidence and refracted angle given or established by a relation called Snell's law. That is n1 sin I equal to n2 sin R. n1 sin I is equal to n2 sin R. So here angle of incidence and angle of refraction. So here in our discussion, theta 1 is angle of incidence. So that is taken to be theta 1. Then here now angle of refraction. It is theta 2. So I is equals to theta 1 and R equal to theta 2. Substituted. Then I got a relation n1 sin theta 1 is equal to n2 sin theta 2. This is called Snell's law. n1 sin theta 1 is equal to n2 sin theta 2 is now taken to be Snell's law. So now we are substituting angle of incidence and angle of refraction values. Angle of incidence and angle of refraction values in the relation. So what I can substitute that theta 1 and theta 2 values in the Snell's law. So I know theta 1 is equals to alpha plus beta and theta 2 equal to beta minus gamma. So here I can write relation as n1 sin alpha plus beta equal to n2 sin beta minus gamma. I got a relation using angle of incidence and angle of refraction values as theta 1 and theta 2. So this equation I am representing as u here equation 1. As equation 1. Then I will consider a situation, especially I will consider a situation using angle alpha. Using angle alpha. So what is here angle alpha? The angle made by the incident light ray with the principal axis. Alpha is angle made by the incident light ray with the principal axis. So what happens if the angle of incidence, angle of incident light ray made with the principal axis, that angle made by the incident light ray with the principal axis assumed to smaller, very, very smaller. Alpha becomes smaller. Then what happens to the light ray? It is becoming very close to the principal axis. It is becoming very close to the principal axis. So in this case, we will select that light ray very close to the principal axis. So maybe this color not visible. I'll change the color of that light ray somewhat darker. So now look at that light ray. Very close, becoming very close to the principal axis. Suppose somewhat decreased angle. So again, the alpha becoming very smaller. So when you take a light ray with smaller angle, right? So that light ray is called a paraxial ray. Paraxial ray. The light ray which is very, very close to the principal axis, that means making angle with the principal axis very smaller. That light rays are called paraxial rays. Then that paraxial rays we will approximate as parallel to the principal axis because the alpha will be very smaller and negligible. So they consider to be parallel to the principal axis. The light rays which are very close to the principal axis and making very smaller angle called a paraxial light rays. That light rays considered to be parallel light rays called a paraxial approximation. So that approximation is called a paraxial approximation. So when the alpha will become smaller, very, very smaller, then we can approximate that sin alpha plus beta is alpha plus beta. This is called approximation. Because alpha plus beta value is very, very smaller. That sin of alpha plus beta will give you very, very smaller, and there is very small variation between sin of alpha plus beta and alpha plus beta. That's why you are approximating is that sin alpha plus beta equal to alpha plus beta. Then you can imagine, guess sin beta minus gamma equal to, that is also approximated as beta minus gamma. So approximated, then substitute that values in the equation 1. What happens when you substitute these values in the equation 1? Simply we will get from the equation 1, n1 into sin of alpha plus beta will be written as n1 into alpha plus beta equal to n2 sin of beta minus gamma. So here sin of beta minus gamma approximated as beta minus gamma, we can write as n2 beta minus gamma. So now expanding that, n1 into alpha, n1 alpha plus n1 into beta, n1 beta is equal to n2 into beta, n2 beta minus n2 into gamma, n2 gamma. So that we are taking as relation number 2 now. Relation number 2. So equation 2 I got on the screen. So now we'll go for another. So here I want here what are alpha, beta and gamma. I know n1, n2 and any other? No. n1, n2 refractive indices of respective mediums called rarer medium and denser mediums. Then what about this alpha, beta, gamma? They are very smaller angles, right? So here what that values? So we can find out here that alpha, beta, gamma values. So for finding, simply I am depending a relation called tan theta. So I know tan theta equal to, from the trigonometry, tan theta equal to opposite side by adjacent side. Opposite side by adjacent side. So from the trigonometry, you will get a relation from tan theta equal to opposite side by adjacent side. So for that, we are considering only the right angular triangles. Only the right angular triangles, include the angles alpha, beta, gamma. That which includes alpha, beta, gamma. So here simply for all the right angular triangles, just I'm giving you an idea using here right angular triangle. So look at, I'm taken a right angular triangle and giving the vertices as A, B, C. Then I have right angle at a vertex B. So you have a right angle at B. Remaining angles are other than right angles, maybe smaller or greater. So in a right angle triangle, that remaining two angles are very, very smaller. Suppose if you have an angle theta at A, then to find out the theta value, so I have a formula tan theta, that is equal to opposite side to the theta and adjacent side to the theta. Opposite side to the theta and adjacent side to the theta. So we can write tan theta is equals to opposite side in the triangle ABC is theta opposite. So go like this. So opposite side is BC and adjacent side is, so adjacent side to this one is now AB. So what the tan theta will be written as? Will be written as BC by AB. So like this we can write. So from the diagram, what we have the image on the screen, from that I am using the right angular triangles here. I'm using the right angle triangles. So find out alpha. So I can take tan alpha. So which triangle you can consider here? The triangle you are considering here, simply the triangle is ONA or N. So no, ANO. From the triangle ANO. So now look at that triangle ANO. So in this, where is alpha? Where is alpha? So here that alpha is at this spot. Here is their alpha. Here is there. So using this one, tan alpha equal to opposite side. Which is opposite side? That opposite side is AN and adjacent side is ON. So we can write tan alpha equal to AN by NO. AN by NO. Similarly, tan beta equal to. So where is tan beta? Where is tan beta? That you have to find out with right angled triangle. So include that. So where you have that? Here beta is at this spot. So from there I am giving you like this. So in this region you have a right angle triangle, that is ANC. Triangle ANC. So in that triangle, find out tan beta equal to triangle ANC. So here, where is your angle? Beta is here. Opposite side is this one, AN. Adjacent side is this one. So we can write simply AN by NC. Similarly, tan gamma equal to, in the triangle, which triangle is that? It is triangle ANI. Triangle ANI, that is including the gamma. So gamma, tan gamma is equals to, opposite side to the gamma is AN by NI. So we are written. Then already I told you approximation. What is here? Alpha is very smaller. Alpha is very smaller. So what happens? The light ray, which is incident light ray considered at a point A, becomes very close to this pole. When the light ray very close to the pole, what happens to the point N here? So that point N also here become very close to the pole. So it moves. So here simply I am showing you at this place. Here when the light ray is at the spot A, it is making the angle alpha. Now the light ray is considered very close to the principal axis, like this. So what about your angle alpha? Smaller. Then refracted light ray is very small. So angle gamma and beta also becomes very small. So that's why here simply alpha, beta, gamma becoming very smaller. So we can approximate, as we approximated here, sin alpha plus beta equal to alpha plus beta. Approximating this tan alpha is alpha. Then tan beta is beta. Tan gamma is gamma. So simply I have now the values for tan alpha is alpha. So here only we will consider this portion. So alpha is equals to AN by NO. Beta is equals to AN by NC. Gamma is equal to AN by NI. So neglecting this, what they are here, simply neglecting the tan alpha, beta, gamma, no importance for that, because approximated. So according to this approximation, tan alpha equal to alpha. So alpha equal to AN by NO, beta equal to AN by NC, and gamma is equal to AN by NI. So now we'll go for another. So substituting that values in the equation number 2. Substitute alpha, beta, gamma in equation number 2. Then what happens? Observe. So remove that image. Now here substituting the values. Substituting that values. So simply we are going to substitute that alpha, beta, gamma values in the relation 2. So now n1 into alpha. Alpha equal to an by no. Substitute an by no. Substituted. Next plus n1 into beta. n1 into beta value an by nc. Substituted. That is equal to n2 into beta an by nc minus n2 into gamma. n2 into gamma value is an by ni. Substituted. Then now, is there anything commonly in a equation? What you substituted? In that, there is a common term in all the terms. In all the terms, commonly, we notice that an. So take that an common from the above equation. So an common, what is remaining here? Into n1 by no. n1 by no. Then in the second term, plus n1 by nc is remained equal to an common. What is remained? n2 by nc minus n2 by ni. So an is common. Now we are able to cancel them. Both sides an is common. Then let be cancelled. So let it be cancelled. An and an cancelled. Then here, what about this ni, no, nc? What about this ni, no, and nc? So in the diagram, we approximated that light ray incident very closer to the principal axis. So here alpha is smaller. Then what happens when you draw a perpendicular? That is also very close. So this n point also moves towards left and certain place that n coincides with p. So n neglecting. So now here in all these, what we can do? That ni, no, and nc are replaced with a points called p, pi, po, and pc. Pi, po, and pc. So here now I know pi, po, pc. Look at that. At the beginning I mentioned already here pi, pc, and po. So already I have them. Then let us substitute that values in the above n1 by no. There is, so we can substitute in that. So when you substitute that values, n1 by po we can write instead of no, plus n1 by nc replaced by pc. So n1 by pc, that is equals to n2 by nc, n2 by pc minus n2 by ni, n2 by pi. So substituted. Then next, here I am taking here simply which has commonly in the denominator pc. That terms same side. Then remaining terms another side. So here now this n2 by pi taking left side. So n1 by po plus n2 by pi is equal to n2 by pc minus n1 by pc. So pc is commonly available. So common denominator I am writing right side. So I will get n2 minus n1 by pc. So this relation is simply giving the relation between. But here simply I consider this equation only for the particular situation. To generalize this situation for any curved surface in any condition, what I am doing here, applying the sign convention rules to generalize this equation, right? To make it true for any case. So now we are going for rules of sign convention. sign convention. So what are the rules of sign convention that we will learn here? So rules of sign convention. So what are the rules of sign convention? All the light rays, right? We are instanting on the surface. Okay. After that, you will get an image. Maybe it is real or virtual. Then you are able to measure the distances, object distance to image distance to radius of curvature. So that are considered from the same point. All the distances must be measured from the pole or the optic center. So look at here. I have a curved surface, pole. Then here simply you have center and the curved surface. That distances you need to measure from the pole only. Either sides, maybe towards the left or maybe towards the right. So here, if you measure anything, that parameter must be measured from the pole only, left side or right side. Start from the pole. That is the meaning. Then here, simply, if you measure that anything in the direction of incident light ray, right, along the direction of incident light ray, taken to be positive. Suppose here, see that green color light ray is incident light ray. So it is towards right on the screen. Okay, if you are measuring that light rays opposite in the direction, negative, in the direction positive. Suppose here measuring towards right. So incident light ray directed towards right, and that measurement also towards right. So taken to be positive in the direction of incident light ray. Suppose if you are measuring that opposite to the incident light ray, then it is taken to be negative. So negative direction. Next, above the principal axis, heights we can measure. If the height is measured above the principal axis, taken to be positive. If it is measured below the principal axis, taken to be negative. So these are the rules of sign convention. According to this, we can apply that sign convention in this equation. So here, simply radius of curvature. Here you are measuring. So incident light ray this side, radius of curvature towards this side you are measuring. So positive, it is taken to be positive. Object placed at this side, so measuring in this direction from the pole, so taken to be negative. Then what is image distance? So image is obtained this side. So where you can take that? Simply positive side. So simply sign conventions we can apply. Object distance is negative, image distance is positive, and radius of curvature also positive. Then substitute the values in the n1 by PO and n2 by PI equal to n2 minus n1 by PC. So substitute it. By substituting, what we will get? n1 by PO is minus U, and n2 by PI is V. So positive term I will take first and negative term next. So here simply n1 by minus U plus n2 by V equal to n2 minus n1 by PC equal to plus R. Substituted. So first positive term, next negative term. So n2 by V minus n1 by U is equals to n2 minus n1 by R. You will get a relation. So this relation is called simply curved surface formula. From this you are able to derive plane surface formula that we will discuss in tomorrow's class. So maybe you are clear about this today's topic. We derived curved surface formula. Then applications also there on this curved surface formula. So maybe you are feeling happy with this class. If you like this class, just please give me your valuable comment on the comment section, and also